Welcome back. What we're going to do is today we're going to take a look at how lasers work. Lasers are very fun, very exciting. I love to play with lasers, but also just think about everything that lasers are in. They're in CD players. They're used in fiber optics cables for high-speed communications. They're more than just little laser pointers, stuff like that. We use them all the time, constantly. A lot of times we don't even realize that we use them. Now, this is just the basics of how lasers work. This is just a freshman level physical science course. So, basically, in a laser, we have like a tube-like structure. And inside that tube-like structure, we're going to have a whole bunch of different atoms. Now, it could be different types of atoms, and that's going to help dictate what color the laser actually is. I'm just going to use my laser pointer. It's a helium neon laser, and so these are helium and neon atoms. A lot of times they're always filled with noble gases. Okay, so we got nice little atoms in there. Next thing we need is a power source. Now, just to represent a power source, I'm going to draw a very ugly battery here. Here's my nice little battery, and that powers up the atoms. The atoms get excited. Now, this isn't exactly what's happening, but you can think of the electrons are orbiting at a higher level. Okay, now that's more of a Niels Bohr type thing. They're really not, but you can think of excited atoms. They have extra energy in them. Okay, now what we need then is something to trigger or something to get it started. Now, in an atom, there's a bar that releases a whole bunch of photons. I'm only going to draw it by one photon. So I got one little photon being released, and it's going to hit this atom. Now, this is the most important part of how lasers work. If we have an atom that's excited, as extra energy, and a photon hits it, what's going to happen is two photons are going to come out. Now, it's not just two photons, but these photons are in step. They're completely parallel to each other. If you think about them in waves, you could think the crests line up, the troughs line up. They're just perfect right along with each other. And that's basically how a laser works. A photon hits an excited atom, making two in-step photons. Okay? Now, obviously we need more than that. We have the two little in-step photons. Those guys are going to hit more atoms, and those are going to make more photons coming on through. Now, we still don't have a laser, because if we had this, once we hit the button, we would just have a flash, or we'd have one beam of light coming out. So what we need is mirrors on each end. Okay, so I'm going to put a mirror on this end. I'm going to put a mirror on this end. Now, what happens then is these photons, they fly on through, making more photons that are in step. They're going to hit the mirror, and they're going to bounce back in. They're going to make even more photons. And then they're going to hit the mirror. They're going to bounce on back, making even more photons and more photons and more photons. And all these photons are in step, completely parallel and everything. Now, right now we just have a tube full of light. We don't have a laser, and that's why whoever makes the lasers, they make one of these mirrors to be not completely reflective. I'm going to say it's like 95% reflective or so. That's going to let some of the light out. Now, the rest of the photons are all being bounced back in to make more photons, but some of the light does come out as a laser. And I mean, that's a very simple explanation, but that's the basics of how lasers, light amplification by stimulated emission of radiation, simple example of how lasers work. Thank you.